All right, let me give you an example of a polyatomic ion. One particular polyatomic ion is known as the carbonate ion. I'll write the name here, carbonate. And you can see the carbonate ion, well, that's a combination of one carbon atom and three oxygen atoms that have in total gained 2 electrons. And so the carbonate ion, it's kind of like a molecule that has a charge. But we call this a poly, meaning many, atomic, meaning atom, ion. So this ion is made of more than one atom, and so therefore we call it a polyatomic ion. In this case, it's made of 1, 2, 3, 4. It's made of 4 atoms. And you can probably guess that, let's say carbonate is going to pair with sodium to make sodium carbonate. I hope you can guess that the formula of sodium carbonate would be 2 sodiums. You'd write it like this, Na2CO3. That would be the formula for sodium carbonate. And you might say, well, why do I need 2 sodiums? Well, remember, we've got to balance charges in the compound. And so since this has a positive 1, I'm going to need 2 of these, correct? I'm going to need 2 positive ones to balance this negative 2 on the carbonate. And there's a sort of a cousin to the carbonate ion, and that cousin to the carbonate ion is called hydrogen carbonate. Hydrogen carbonate, and we're gonna contrast that and compare that to carbonate. So this one is called hydrogen carbonate, and this one is just called carbonate. And this is a common theme that you're going to see with polyatomic ions, that it is often the case that you can add an H plus ion to a polyatomic ion. And you can see if I add these together, well, this positive charge is going to bring this negative charge down 1, which is what we see up here. And of course, you need to bring the hydrogen atom along. And so hydrogen carbonate is going to be HCO3 minus. And we can see, okay, if this was to pair with the sodium ion, which has a single positive charge, the charge is already balanced. So if I was going to write the formula of sodium carbonate, it would look like this. A single sodium paired with the hydrogen carbonate ion, like that. All right, let me introduce you to another one. Another polyatomic ion. We're going to go, actually we're going to do a polyatomic ion pair. SO3 2 minus and SO4 2 minus. In this case, this polyatomic ion is called sulfite, and this polyatomic ion is called sulfate. And it's always the case when you have a polyatomic ion pair like this, where you have, the same atom out in front, but 2 different numbers of oxygens. In this case, we only have 2 different numbers of oxygens. You're going to give the polyatomic ion in the pair that has the higher number of oxygens, you're going to give that an ATE ending. So it's sul for sulfur, and then 8 because this has the highest number of oxygens. And then the 1 in the polyatomic ion pair, that's 1 below the high number. And again, this only works for if there's only 2 of them. This one we give the ITE suffix for the polyatomic ion in the pair with the lower number of oxygens. So this would be called sulfite, and this would be called sulfate. And if I wanted to, for example, write the formula, say for aluminum sulfate, it's going to be a bit difficult, but we should be able to handle this. The aluminum ion, that's a monoatomic ion. I'm going to go to the chart, and here's my aluminum ion, which is it's a metal. It's on the left side of that stair step here. So this is going to be a loser to the left of the stair step, and it's going to lose. It's got 13 electrons. It wants to get 10 over here, like neon. So it's going to lose 3 electrons and gain a positive 3 charge. So I have Al3 plus for aluminum. And then sulfate would be my SO4 2 minus. Oh boy, we got to have a lowest common multiple here of 6, which means I'm going to need to multiply my number of aluminums by 2. And here's where we have to be careful. I'm going to multiply my number of sulfates by 3, right? The negative 2's got to get multiplied by 3. But I don't want to just put the 3 right here because that's going to look like SO43, and there's not 43 oxygens in the compound. So what we do to indicate we need 3 sulfates is we bracket the sulfate in a parenthesis like this, and we put a subscript 3 down here. And this is telling people, take this 3 and multiply everything in the parentheses by 3. So there's 3 sulfurs, there's 12 oxygens, and of course there's going to be 3 negative 2 charges for a total of negative 6 to balance the total positive 6 from the 2 aluminums. So the formula for aluminum sulfate would be Al2SO4 parentheses 3. That'd be the formula for aluminum sulfate. And just like there's a hydrogen version of carbonate, where we have hydrogen carbonate and carbonate, we also have hydrogen versions of sulfite and sulfate. And you can probably guess what the names for those would be. We have HSO3. That's going to just have a negative 1 charge compared to SO3 2 minus. Remember, adding the H plus brings that charge, that negative charge, closer to 0. And then we're going to have HSO4 with a negative charge, and that's going to be SO4 2 minus, its pair. We call this one hydrogen sulfite, and this one we call hydrogen sulfate. Or of course this is sulfite and this is sulfate. And just to, show you the language that you're going to have to get used to, if we have just a single monoatomic ion that's formed from sulfur, that's S2 minus, and that becomes sulfide. So just giving you an idea here of all the different names that you're going to need to know. And you might say, well, how in the world am I going to have, all of these ions in my vocabulary? Well, I hate to tell you this. I don't know how else to tell you how to do this other than to memorize. Looks like a long list. You're going to need to memorize this list of polyatomic ions, which I've talked about up to this, right through here. I've talked about these ions here so far in this lecture, and we'll cover some of these other ones. But, when I was learning my polyatomic ions, I made a bunch of flashcards where I would put the name of the ion on one side of the flashcard, and I'd put the formula and the charge, all of that's important, on the other side of the flashcard, and we would, we'd drill them. This needs to be part of your vocabulary, of your chemical vocabulary. I'm going to talk about some more of these. I think there's a few more that I'd like to go through just to highlight. We're going to start with the phosphate ion. The phosphate ion is PO4 3 minus. We call this phosphate. So a combination of 1 phosphorus and 4 oxygens that has 3 extra electrons, we call this phosphate. And this can gain a proton and become hydrogen phosphate, in which, this charge is going to become 1 less negative. So we call this hydrogen phosphate. But this can do this trick once more, right? We can add another proton to this, another H plus, and get H2PO4, and now this is going to go down to a -1, and we call this one dihydrogen phosphate. So there's sort of a triplet of phosphates in which the phosphate can gain either 1 or 2 protons. And if we were going to write the formula, say, for sodium phosphate, well, we're going to, sodium's at +1 charge. We're going to need 3 of these to balance that -3. And so the formula for sodium phosphate would be Na3PO4. And that's your formula for sodium phosphate. Challenge for you is to find the formulas for sodium hydrogen phosphate. You're going to need 2 sodiums in that one, right? And also the formula for sodium dihydrogen phosphate. In that case, you're only going to need 1 sodium ion. If you're not following that, pause the video and work it through. Okay, let's talk about the next group of ions in our list of polyatomic ions. So to this point, what have we talked about? We've talked about these 3 here. I'm going to skip chromate. That's just one you ought to know about. Let's look at this pair here, nitrate and nitrite. So nitrate is NO3 with a negative charge, and nitrate is NO2 with a negative charge. And we see this theme again, that if we have a polyatomic ion, a pair of them, so just 2 of them, in this case, we're going to give it the nite for, nitrogen, but this one we're going to give the ATE ending, because in the pair, this one has 1 more oxygen than the nitrite in the pair, where we give the one with 1 fewer oxygen in the pair, we give that the ITE ending. And we'll contrast this even with the nitride ion, the monoatomic ion, which happens to have a -3 charge, and you can tell this from its position on the periodic table. You can always tell the charge of a monoatomic ion from its position on the periodic table. How close is it to the nearest noble gas? These you're going to have to memorize. There's no other way around it. The last set of anions that I want to go over is this one. It's going to be ClO4 minus, so that's a chlorine and 4 oxygens. And then we have a ClO3 minus, but doggone it, this one is not just a pair. This has 4 of them. So what are we going to do here? I can't use the ite category to distinguish between all 4 of these polyatomic ions. How are we going to do it? Excuse me. Well, here's what we're going to do. What we're going to do is we're going to pretend that this is the highest number of oxygens, even though we know it's not. And we're going to call this one chlor for chlorine, 8. I know I'm cheating right now, but like in the normal scheme of things, we'd want to give the one with the most oxygens the ATE ending. But in a second, you'll see why we do it this way. This one we're going to call chlorite because it has 1 less oxygen than chlorate. Okay, then what we're going to do, we're going to call this one up here perchlorate. And you might be, well, why are you calling it perchlorate? Well, someone who's hyper kind of has more energy. A kid that's hyper has more energy than normal. And so I kind of think in my head when I hear perchlorate, I think hyperchlorate. Of course, this is not in the name. And this is telling me, hey, this has even 1 more oxygen than chlorate. That's what the per is on there for. It's hyperchlorate. And then down here, we use hypo. Hypo means low. Hyper means high. So this one is hypochlorite. And this is telling me, aha, this one has 1 less oxygen than chlorite. And I'm just going over all of these polyatomic ions to give you some clues, some ways to help you memorize these names. That's my goal for doing this, and also to go over a little bit of the naming as well. There is one ion here that's a cation that I want to point out. That's the ammonium ion. That's going to be an important one for us. The ammonium ion, it's our only polyatomic cation that I'm going to have you worry about. It's NH4, so it's a nitrogen and 4 hydrogens attached. And this we give the name ammonium. Okay, so we have our lists here. We're now going to go through and we are going to try to write some formulas for some of these ionic compounds that have polyatomic ions in them. So here's what we're going to try. I want you to try this. We're going to go ammonium sulfide. That's one we're going to try. We're also going to try calcium carbonate. Okay, we'll work through those. And then I also want us to try, let's do iron 3 sulfate. And we're also going to try zinc dihydrogen. Run out of room here. Phosphate. Okay. So how are we going to name these? Well, I mean, having these names and formulas memorized is going to be key for you here. If you don't have them memorized, you're going to be out of luck. That's just the way that it is. So when I see ammonium, I immediately know I've got the ammonium ion, NH4 with a +1 charge. I just know it. Of course, I've been doing this a while, but it's, I caught on pretty quick when I first had to learn this stuff. But like I said, I had to use flashcards. So I've got my ammonium ion, and then sulfide. Hey, that's an IDE ending. That's telling me that this is a sulfur, just a single sulfur. That IDE is telling me that. And I need to figure out the charge on the sulfur. So I go to my periodic table. I check out sulfur's position. It's sitting right here. Wants to gain 2 electrons. Hey, that's going to be a -2 charge. So this is going to be an S with a 2-. Well, those charges don't balance, but hopefully you see that if I get 2 ammoniums, that'll do the trick. So remember, if I need to designate more than one polyatomic ion, I put it in brackets, in parentheses, put a little 2 down here, and then I write my sulfide ion. So the formula for ammonium sulfide would be written as follows. Calcium carbonate, well, calcium, that's just telling me the atom that makes the cation in this case. It's right here, so that's going to be +2, right? Going to lose 1, 2. So my calcium is going to go +2. I happen to know the charge and symbol for the carbonate. That's CO3 2-. And hey, those balance. Those balance, so the formula for calcium carbonate is simply CaCO3. We can try the same here for iron 3 sulfate. What's nice about this is iron 3, it's telling me the charge on the iron, so I'm just going to write Fe 3+. The sulfate ion I know is SO4 2-. Lowest common multiple of 3 and 2 is 6. So I've got to multiply this by 2, and I've got to multiply this by 3. So I'm going to write it like this. Fe2SO4 3. That would be the formula for iron 3 sulfate. And just to tell you here, iron 2 sulfate would simply be FeSO4. I'll just write that here, and maybe you can figure that out on your own. Iron 2 sulfate, its formula would just be FeSO4. Finally, we're going to do zinc dihydrogen phosphate. Zinc is one of these transition elements that its charge is always known. Both zinc and silver, where's silver? Right there, zinc and silver. Zinc is always +2 when it's an ion. Sulfur is always +1 when it's an ion. Those are rare in terms of the transition elements. Most of the transition elements are going to have a charge that varies, but zinc is always +2, Silver is always +1. So if I write the zinc ion, I don't need to put zinc 2 here because everybody knows zinc is always +2. So I'm going to write my zinc 2 plus. Dihydrogen phosphate. Well, I can't remember. Let's see. Phosphate is PO4 3 minus. And if I add a hydrogen to that, it's going to be HPO4 2 minus. And if I add 2 hydrogens, that's going to be H2PO4 with a -1 charge. So that's going to be paired with H2PO4 with a -1 charge. And of course, I'm going to need 2 of these, aren't I, to balance that +2 charge on the zinc. So this is going to be Zn H2PO4, and I need 2 of those. And that would be the way you write the formula for zinc dihydrogen phosphate. All right, that's going to wrap it up. And in the next video, we'll move on to writing formulas for molecular compounds.